3I/Atlas, the time capsule. The end of speculation. December 18, 2025. NASA headquarters, Washington, D.C. The press room was packed, not with conspiracy theorists, but with scientists, journalists, and students, united by one question. What is 3I/Atlas? Dr. Linda Chun, NASA's chief scientist, stepped to the podium. Behind her, a single image glowed on the screen. HIRS's view of 3I/Atlas, captured during its October 3rd flyby past Mars. After weeks of silence due to the government shutdown, she began, "We owe you the full truth." She clicked. The image zoomed in. A dusty coma, a bright, compact nucleus, a dynamic tail stretching into darkness. No panels, no symmetry beyond natural fracturing, no artificial lights. "This," she said, "is a comet. An interstellar one, but a comet nonetheless." She detailed the multi-mission campaign. MAVEN's UV spectra, CO2, water, traces of organics. Stereo's wide-angle views, tail evolution during perihelion. Lucy and Psyche, opportunistic distant snapshots. HiRISE, 25 centimeters per pixel resolution, showing a textbook nucleus, pitted, irregular, but whole. Do anomalies? Chun smiled gently. Viewing artifacts. Processing glitches. The chaos of a fast-moving object seen through limited data. The room exhaled, not in disappointment, in relief, because the truth was more beautiful than the myth. The return of data. December 19, 2025. Global science community. For 37 days, the government shutdown had created a void. No updates, no context, just raw data trickling through back channels, and wild speculation filling the silence. Now, NASA released everything. 12 HiRISE frames, 48 hours of MAVEN UV spectroscopy, Stereo's full perihelion sequence, Lucy's distant photometry. Avi Loeb, reviewing the data at Harvard, felt not embarrassment, but gratitude. "The shutdown forced us to wait," he told his team. "But waiting gave us clarity." He showed them MAVEN's gas profiles, CO2 sublimating as the comet neared the sun, then water emerging as deeper layers warmed. Perfectly natural, perfectly expected. And HiRISE? The nucleus was not smooth. It was rugged, craters, ridges, fractures from ancient collisions. Not a probe, a wanderer. "The universe doesn't need to send us machines to speak to us," Loeb said. "It sends us stories, written in ice, sealed in dust, delivered across billions of years." The real revelation wasn't artificiality. It was time. The Ancient Traveler. December 20th, 2025. JPL Science Briefing. Dr. Rajiv Mehta presented the timeline. 3I/Atlas formed before the sun existed, he said, in a star system that died billions of years ago. It drifted through the galactic disk, bombarded by cosmic rays. Its surface darkened, its ices transformed. He showed models. 7 billion years of cosmic ray exposure, CO-rich ice converted to CO2 crust. High velocity, 58 kilometers per second, dust tails stretched, jets curved. Ancient composition metal ratios reflecting early galactic nucleosynthesis. "This isn't just a comet," Mehta said. "It's a fossil, a sample of planetary formation from an era we can't observe directly. And its journey? Not a targeted mission. A cosmic accident, ejected from its birth system, flung into the void, caught by the sun's gravity by pure chance. Yet in that accident, meaning emerged. Because 3I/Atlas proved, the ingredients of planets, and perhaps life, are universal. Its CO2, its organics, its silicates, they matched models of early solar systems. We are not unique. We are part of a pattern. And as it faded into the outer dark, it left behind not fear, but belonging. The Chemistry of Time. December 22nd, 2025. Johns Hopkins University, Baltimore. Dr. Carrie Liss stared at MAVEN's ultraviolet spectra and felt tears well in her eyes. Not from awe, from recognition. The lines on her screen, CO2 at 140 nanometers, water at 165 nanometers, traces of cyanide at 190 nanometers, weren't alien. They were familiar. "This is the same recipe," she whispered to her team. "The same as Hale-Bopp, the same as 67P, the same as the comets that seeded Earth. But with a twist. The CO2 to water ratio was 7.6 to 1, far higher than solar system comets. At first, it seemed bizarre. Now, it made perfect sense. Cosmic rays, she said, pulling up models of interstellar ice irradiation. For 7 billion years, high-energy protons bombarded its surface, breaking CO bonds, forging CO2, baking organics into tholins. She showed side-by-side lab experiments. Ice mixtures exposed to particle accelerators for weeks, mimicking millennia of galactic exposure. The spectral match was exact. 3I/Atlas wasn't strange. It was aged. Its surface wasn't primordial. It was a palimpsest, written over by the galaxy itself. And in that rewriting, a deeper truth emerged. The universe recycles everything. Stars die, planets form, comets drift, and the same carbon, oxygen, and hydrogen flow through them all. We thought we were studying an alien world, Liss said. But we were studying ourselves, as we might have been, in another star system, billions of years ago. The Universal Recipe. December 25, 2025. European Space Astronomy Center, Madrid. Dr. Sofia Ruiz led the team comparing 3I/Atlas to 2I/Borisov, the only other interstellar comet with detailed data. The results were humbling. Borisov, water-rich, CO-poor, formed in a cold outer disk. 3I/Atlas, CO2-rich, water-poor, formed in a carbon-rich environment, then processed by cosmic rays. 2 comets, 2 star systems, 2 stories, Ruiz told ESA's Science Council. But the ingredients? Identical. Both contained silicates, organics, ices. Both showed evidence of radiation processing. Both followed the same physical laws: sublimation, dust dynamics, tail formation. The galaxy has a standard model for comets, she concluded. Variations exist, but the blueprint is universal. This wasn't just astronomy. It was cosmic democracy. No star system is special. No planet is alone. The same chemistry that built Earth's oceans also shaped 3I/Atlas in a cradle of light now long extinguished. And as it passed through our solar system, it didn't bring alien technology. It brought confirmation. We are not a fluke. We are inevitable. The legacy of a wanderer. December 28, 2025. Vera C. Rubin Observatory Site, Chile. Engineers powered up the final systems of the Vera Rubin Observatory, its 8.4-meter mirror gleaming under the Andean stars. Beside them stood Dr. Eris Thorne, HIRSE's lead, now advising on interstellar detection protocols. 3I/Atlas taught us a hard lesson, he said. We saw it too late. By the time it reached Mars, its surface was already altered by the sun. Rubin would change that. With its 10-year survey, it would detect interstellar objects years before they entered the inner solar system, while they were still pristine, untouched by stellar heat. And waiting at L2, ESA's Comet Interceptor stood ready, a spacecraft designed to rendezvous with the next visitor, sampling ice before cosmic rays or sunlight changed it. This isn't the end, Thorne said. It's the beginning of interstellar sample return. He thought of 3I/Atlas, now fading beyond Jupiter, its tail dissolving into the solar wind. It hadn't brought aliens. It hadn't threatened Earth. It had simply passed through, like a leaf on a galactic river. But in its passage, it left a gift. Perspective. We are not the center of the universe. We are part of its story, written in the same stardust, shaped by the same forces, bound by the same laws. And every comet that visits us is a letter from home.